So I'm just going to start this video now. I'm not going to explain what this is because I don't know what it is yet, but we are going to do some problems today. Some Codeforces problems at around about 1300, and then we'll see where to go from there, but I'll explain why a bit later. So yeah, I'm just gonna give you enough of an introduction. I don't think you need more than that. It's probably the one guy that I sent it to that's gonna watch this, but yes, you're here now. Okay, cool. I guess I should probably take these glasses off, but I won't. Let's keep it on. This will be the first episode, and then we can gauge where we stand with the sunglasses. Maybe I like them, maybe I don't. Maybe you like them, maybe you don't. I don't care. But we're gonna try and solve some problems. So I guess let's do a bit of admin at least. So I use VS Code. I program in Java, and I am solving some Codeforces problems because, well, I'm not going to solve any Code Chef problems, but yeah, we're going to see how many problems we can get through today. And I've got a little bit of a bone to pick with you, with me, with myself, and with an infinitely sized Cartesian plane. So this problem, I've seen this one before. I've read through it before, but I'm just going to start to speak about my issues with it and why it bothers me so much. So this problem involves some robot. Who knows why they said robot? But you're standing at the origin of some plane, and you take steps from your current position. So say you start at 0, 0, you can move in the 4 standard cardinal directions: north, east, west, and south. And then every move after that has to be 90 degrees to the left or to the right of where you currently moved. So say you moved north, you have to move east or west. Say you move north, then you have to move east or south. No, east or west. What am I saying? If you had initially moved east, you have to move north or south. If you had initially moved west, you have to move north or south. My apologies. My apologies. But I feel like we'll get better at explaining at some point, but I have to start making more mistakes with my explanations, so bear with me. You should probably skip these parts, but yeah. So I got this notebook, pretty cool notebook, and it's a notebook, and I've got my notes in here, and we're going to try and solve it. And then if I think I've caught onto something, then I'll draw it up on OneNote, and then hopefully I can explain it. In the meantime, enjoy the tunes, enjoy the music. Hopefully, it's no copyright for no good reason. I mean, I programmed this some time ago, but I just need to debug it because it failed. It failed test 3, I think. Test 4. Oh gosh. Wait, can I see what I got wrong? 777 steps. That's not cool. And I'm way off as well. Okay, I'm gonna see if I can remember my original idea to the solution, but until then I'm just gonna try and draw it up. Maybe it comes back to me. bear in mind this is a DP problem, so that kind of makes it a bit more interesting because we can solve this in steps. So I feel like the initial question we need to ask ourselves is, hey, how many different positions can we end up after one step? We could end up over here, right there, or even there, having moved north, east, south, or west. But from there, we notice that in two different sequences of movements, we can end up in the same place. So now we have to start accounting for duplicates, but I couldn't think of an efficient way to remove the duplicates or to calculate duplicates, and I think that's the well, of course that's the problem. But I've got something else. So let me just draw up for two steps all the different places we can end up, and it's going to be in pink now. So we could end up there, or there. Now I'm going to do 3, and then I'm going to explain where my idea for the solution comes in. So let me just zoom in a little bit. So now say we had moved 3, we could have ended up here. Just gonna draw like these scribbles. Could have ended up there, even there. And then something magical is about to happen. Trust me. I'm just struggling to stay consistent with my lines, but that's about it. Yeah, you can see somewhat of a pattern, and I'll explain why. I mean, I was explaining this to my friend the other day, and I completely choked on my words as I am now, but I hope he's watching, and I hope you're listening. Yeah. I'm talking to you, risk management. Yeah? You know who you are. Okay. Okay. So now the white steps represent 3. So let me just draw somewhat of a legend for you that are curious. And green was 1. No, green was 1. Blue was 1. Okay. So there's a step that I want to show you. So the key to this problem is that we cannot duplicate some move. So I can't move north and then south, or I can't move north and then north, or the same goes for any other direction. So we're going to notice a consistent change in the x and in the y axis for some n number of steps. So say for 3 steps, these white positions. Notice that, for example, this one, the one that I've just encircled in cubed, is 1 to the right of me and 2 up. That change sums up to 3. What about this one? It changes 2 on the x, and so it changes 2 on the x, and it changes 1 on the y. Sum is 3. This is consistent for all of the other white points except these 4. So these 4 are interesting because notice that, every I don't know how to use my words for this, but I could move down and then up again, in other words, cancelling out some move that would have been evident in the last position. So say I moved 1 to the right. This is a valid 3-step move because I could have moved down and then right and then up again. So that downward move gets cancelled out by that upward move. And yeah, we have to take that into account. So say let's not say, rather I'm going to draw what I want to describe to you quickly. A bunch of triangles. In fact, there will be exactly 8 of them. I'm going to try to draw them as neatly as possible. I say that ironically, by the way, but yeah. So, what's that reminding me of? Wait, I need to see something. Yes, for my WWE watchers over there, man. Triple H, the king, the legend, can be described with this problem right there, man. They're the same thing. They're exactly the same. Okay, this is going to be a Triple H video. I'm going to put him in the thumbnail or something. Nevertheless, here's what we need to remember. That for 3 steps, we know that only valid moves can be the number of ways that we can sum 1 and 2 to get 3. So either we can have a change of 1 in the x and 2 in the y, or 2 in the x and then 1 in the y. But then we also have to account for these inner points, those 4 original points that we could have cancelled the 2's out for. So we can also then say, hey, but that 2 in the x or that 2 in the y can get cancelled out. So in fact, we can also then say 1 in the x and 0 in the y, or 0 in the y, or 0 in the x and 1 in the y, and then that sum will give us the total number of possible outcomes that we could end up. The challenge now is putting this into an algorithm, and that's what we need to do, because I think one interesting point about this problem is that they only give us one value. So there isn't some tricky log of n solution or O of 1 solution that we can do. It's one. There is going to be some iterative algorithm, and then that's at least my first assumption. I might look at the solution and then see later, but that's what I assume.
You're invited to a new way of listening with
I don't have Spotify Premium, okay?
Lets you connect to your speakers or TV
Make
and listen to your
sponsor
music
me.
ad-free. With
Skillshare.
easy setup, you can connect to any compatible device
Only
and enjoy music without interruptions.
Skillshare.
Plus,
If you don't want to hear
listen on demand and play any
and it's
song
South African
anytime,
Spotify Premium,
even on
okay?
mobile.
No, South African Spotify
Upgrade now
ads,
to
okay?
Unlock Premium. Tap
You're gonna
the
hear
banner
one in
to
another
learn more.
language now. It's gonna be Afrikaans. Then you're not gonna know what's going on. Do you wanna be that person, or do you wanna sponsor this channel? I'd sponsor it if I was you. Yeah, you heard me. What am I doing? What's going on today? Anyway, my glasses all dust up, man. I just took these out for the first time. Am I a barbarian? Man, I have a cloth. See, I'm a man of culture. Man of culture. I'm sorry if it's all static. It might just be static and it might irritate the life out of you, but that's all I got right now, okay? That's all I got. So as I was saying, I've just got my train of thought back. Okay, so this becomes DP for some reason. These are our two base cases? Are they base cases? I'm not sure if I can call them a base case. This is not going to be recursive, by the way. I should probably think before I speak, so let me think for a bit. I mean, one thing I could say is that I know that for some pairing where the values aren't equal, I can switch those two around. So for every pairing there's four different transformations of it. So say for instance a change of 1 in the x and 2 in the y, like this triangle fits that criteria, so does this one, so does that one, and so does that one. But then I could flip 1 and 2 around, and then I can get 4 more variations in these 4. So then I've got 8 for this set. So then I have 8 for that set, and then in this scenario I have, well, how many ways can I do, well, not sum, transform 1, 0, change of 1 in the x and 0 in the y. I can do that twice. Okay, I can do that twice, so then I can do that 4 times. Right? Yeah, so that's true. So if I go and check, this 3 yields 12. So the sum of these are then 12. So this is going to be some wild case for reducing our value for change in x and our change in y all the way until it reaches a 1, 0, 0, 1 or a 0, 0. To account for all of the cancelled moves that we can make. If this is the only problem I solve today, then I'll be a happy man. Why did I take off my glasses to drink? Okay. Okay. What can we do? We're going wrong some way with the larger test cases. Maybe we should draw one. Let's draw. I'm not going to draw it on here. It takes too long. Okay, so it's not of too much help. So I'm gonna test it now for 5. No, I'm gonna test it for even number actually. Yeah, test it for 6. Okay, so 6. See, now 6 is interesting because I can 4-2 is not a change. No, I can't do a 4-2 change. No, when I say 4-2, I mean 4 in the x, 2 in the y. That won't be valid. So 1, 2, 3, 4, 5, 6. Changes 3 in the x, changes 3 in the y. 1, 2, 3, 4, 5, 6. Changes 3 in the x, 1 in the y. And I can make I'm not going to do it again. I might just leave the problem statement up. This is B of 691 division 2. If anyone wants to try it. So for 6, our greatest change in distance will be 3 in x, 3 in y. But then I can cancel out 2 y movements. I can go to 3, 1. I can cancel out 2 x's and I can go to 1, 3. So I believe that theory is okay. But somewhere in my code it goes horribly wrong. And I'm not able to figure out why. Wait, what have I done here? So I have some base case that says if either of them are equal to 0 or either of them are equal, we return 4. So why would I return 8 for some set? So say I start with 3, 3. My code would then say, hey, is x greater than 3 and y greater than, is x greater than 0 and y greater than 0? That is true. So then it's going to say total plus equal the value for 3, 3. 3, 3, both of them being the same value, won't yield triangles, but it will yield squares because they're both the same. What I mean by that is, say I had to move, say it was 2, say I could only take 2 steps, then I'd only be able to make 1 change in the x and 1 in the y. So I could end up there, 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 or there, and then, cool, yeah, that's a square. Squares probably aren't the best way to illustrate this one, but yeah. So because they're the same, I mean it passes that statement, then it's going to end up here. And because they're both the same, yeah, because they're both the same, we return 4. But then in the other example, it's going to say get x minus 2 y. So then it would be a 1, 3 pairing. The 1, 3 pairing would return 8 because neither of them are equal to 0 and they are not equal to each other, so it will return 8. And then in the get x, y minus 2. It'll do the same thing, that'll work. And then And then we just bring both of them down by 2. Let's test this out for 6. What? My code got 24 for 6. Let us validate that. Bruh, I don't know. I swear I've got the idea for this problem down. Where's my problemo? I'm checking 6. So I'm noticing that for the initial pairing 3-3, we get 4 because they're both the same, like I said. Then we can take it to a 3-1 or a 1-3. Then we go straight down to a 1-1, where the 1-1 only yields a 4. So then I get 16 and not 24. But I don't know how I'm getting 24, so let's debug that. I know my total is currently 4. Then it's 12. Oh, that's kind of fishy. That's kind of fishy. So I double down on the 8s. That shouldn't be true. That should not be true at all. And then that should return a 4, and then that will return a 0, and then that will stop, and then that will give me 24. Okay, so I'm doubling down on the 8s. The 8s don't work like that. So when they're equal, we return 4. And the pairing is not equal.
The same go-to meals? Get all kinds of yum
We return 4.
Go on, download the Mr. D Food app and discover over 8,000 restaurants and a world of delicious options.
But I'm adding 8 for 1 3 and 3 1 when I'm adding 8 in the first place to account for the switch initially. So that doesn't work. So I know if some pairing 1 3 works, then I'm not gonna add it. I'm not gonna add that again. Or I should just make them just add 4. In any instance. So yeah, so I'm just gonna test that out. Let's say return 4. Let's quickly just see what this does. Oh, I put 8. Oh, I meant 3. 3 can't give me 8, 3 has to give me 12, but now it's not accounting for something else. So what? So it's testing 1, 2 now. It's testing 1 and 2. What about 2 and 1, my friend? Come on, my friend. You forgot about 2 and 1. That first switch is not. Oh wait. Oh, never mind. That's probably not the best way to do it, but let's just see if it fixes our problem. For now. 6, yeah. Okay. So 6 must be 16. That's what we got now, anyway. XY could be the same, and then I'm doubling for the same thing again. Now you see. So that initial case worked, where I say or for x equals 0, either or y is equal to 0. Then we return 4. Else we return 8 to avoid doubling. Yeah. Then the 3 is 8 now. Why? Because 3 starts at 1, 2. 1, 2 will return 8. So then I get 8 for the 1, 2. And then the 1, 2 is going to become a 1, 0. And then the 1, 0 is going to... The 1, 0 just returns 4 when it should return 8. So that XOR shouldn't take place. The 1, 2 is going to return 8. The 1, 0 is going to return 8. No, it shouldn't return 8. What am I saying? It should return 2 and then double down on the 2. Must return 4. So that is true. Yo, I'm bugging now. I'm bugging up real bad. but let's see. If x is equal to y, or x is equal to 0, or... Well, clearly, I don't know what's going on, because obviously that would mean I return 2 in that scenario. Because then we can't perform a transformation flipped over the axis because it's the same point. So then we return 2. So if only one of them is, then we return 2. But then I'm going to start at 1, 2, get 8. Then I'm going to get a 1, 0. And then that 1, 0 is going to have me return 4 as well. Right? Because then I have to, not only for 1, 0, but also for 0, 1. For 1, 0. Sorry about this problem, man. But it's the fun part. We're gonna fix it. Right? So 1, 2 returns 8. Perfect. Oh, I'm not even counting negative 1. Wow. Wow. That's a stupid bug. I'm having a paradox. This is a paradox again. right under my nose. No pun intended. I think there was a pun in there. I'm not sure. But I'm sort of torn in between if this is the right way to do it, or if this is just a problem where we have to find the number of ways that we can sum up to n, and then that ultimately tells us the number of pairings we can make. But this feels right. I'm just not implementing it correctly, and I'm just having a block, a big old block on a Wednesday afternoon, the day I finish my exams. But yeah, we're gonna sit here and we're gonna think and we're gonna figure it out. I mean, there's probably some guy in Quora that's probably like, well, buddy, you should just probably read the solution, man. Just read the solution and then implement it yourself, man. No. We're not gonna do that. Not in these streets. Not in these streets.
Upgrade to Premium and unlock access to ad-free music. That means any playlist or radio station you want without ad interruptions. With radio stations, create a collection of tracks based on the music you love. On any artist, album, song, or playlist, just click Go to Radio and listen to hours of similar music ad-free with Premium. Tap the banner to learn more.
I'm still getting the same answer, man. What am I missing, man? I'm probably missing... There's probably some logic I'm just not getting. Or some sentence that I never read. The number of different possible locations after exactly n steps. I mean, but that doesn't change. No matter how large the number is, for some pair of x, y, if they're not the same, then I can transform it 4 different ways in the 4 different quadrants. If they are the same, I do it twice so that I don't duplicate it, because that's just for algorithm's sake. But what could be wrong? I guess it's time we gotta read. Now let's see this. I'm describing an O1 formula. First, consider the case when n is even. Okay. Regardless of the initial direction, we will make n divided by 2 horizontal steps and n divided by 2 vertical steps. Further directions of horizontal and vertical steps may be decided independently. If we have k horizontal steps, if we have to make k horizontal steps, choosing left or right every time, there are k plus 1 possible horizontal positions. You know it's peak when you don't understand the solution, but I just need to think about it. if we make k horizontal steps using left or right every time there are k plus 1 possible horizontal positions x we can end up in. Say we take 2 steps. So then k is n divided by 2. So then we got one horizontal step, and then there are 2 places we can go. Either to the left of us or to the right. Either k steps left, 0 steps right, x is equal to negative k. K minus 1 steps left, x is equal to negative k plus 2. Okay, so that makes sense. So, take 0 steps left and k steps right. Back in the case of even n, since the directions for vertical and horizontal steps can be chosen independently, there are n divided by 2 plus 1 squared possible combinations of final x and y. Okay, makes sense for 2. For 4, then k would be 2. And there would be 3 possible positions we could end up in. Why would it be 3? Oh, because we couldn't only have a change of 1. So we would have to have a change of 2. Or no change at all. So okay, so that makes sense. And then for 4 divided by 2 plus 1. 9. Okay. So I'm going to test that for 4 quickly, because that's not how I imagined it, and I probably should have tested 4. But what went wrong with 4? So I could have ended up there, or there, or there, or there. But I could also have ended up there, 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 there. So 0, 0 counts as a position, you say? So that makes a lot of sense. So, to summarize, right? There's a formula we can use to find out the number of different horizontal positions that we can take up. And that formula is consistent with the number of possible combinations that we can finally get. So I mean, he just did that to explain. But I mean, we got the general idea of there will be this many changes in the x and this many changes in the y. Where did we go wrong now? What did I fail to see with doing 4? So I'm going to test 4 again and I'm going to debug it, but I don't know, still don't know what went wrong with my code. Let's do 4. So 2, 2 is a sequence. Then let's hit F9. 2, 2 is 1. gives me 12. So my code must say router. Z, there's too many friggin' duplicates. I'm doing too. Why did I say friggin'? Well, what's friggin'? Okay, anyway, there are a lot of duplicates, and this formula solves it for us. We would have had to keep some sort of memo box to keep track of the values that we've already saved, and that would have taken too long. So, what I understand of this is that for even at least, there are n divided by 2 plus 1 possible combinations. I mean, the same goes for the y if it's even. It's essentially just going to be k plus 1. K would have been 1. Then we'd have to add 1. Square that, and then we get the number of outcomes. It's interesting. Okay. And now let's say that n is equal to 2k plus 1 is odd. If we start with a horizontal step, then in total we will be making k plus 1 horizontal steps and k vertical steps. Yeah, okay, I get that. Thus the number of combinations here are k plus 1 times k plus 2. It makes perfect sense. I'm having no issue understanding it. But I don't know how I missed it. That's what I'm trying to figure out. What does this account for that mine doesn't? Because if mine generates pretty much all the number of sequences, except, in fact, I would even duplicate them. So the issue should be on the other side of the spectrum. I should be generating too much, but I'm generating too little, and I don't know why. Then in total we'll be making k plus 1 horizontal steps and k vertical steps. And the number of combinations here are 1 and 2. Similar argument applies for vertical steps. Finally observe that it is impossible to reach the same position starting with both a vertical and a horizontal step. That's because the parity of, say, the final horizontal position x is the same as the number of horizontal steps. Parity of, say, the final horizontal position is the same as the number of horizontal steps. If you take a vertical step first. So I multiply that answer by 2 because we have different outcomes for a started horizontal or vertical step. And then k is obviously rounded down to create the pairing of 2k plus 1 is equal to n. That's essentially what we did with our double xy, with our floor and ceiling. I'm gonna have to look at that another time, but sheesh. Anyway, let's just put it into the variable.
Tired of having the same go-to meals? Get all kinds of yum you didn't know you needed. Go on, download the Mr. D Food app and discover over 8,000 restaurants and a world of delicious options.
Crazy stuff, man. Crazy stuff. Crazy stuff. I didn't see that, and it's something that I probably will not forget. That you completely slapped me up. Okay. Let's take a break, maybe. Maybe I should do some talking now. Maybe explain what's going on here. Let's just take this off, this problem. Just one. We're an hour in, and we've had to but solution check. But anyway, we move. Let us do another problem in the DP set. No, wait, first I need to talk. Okay. Here's what we're going to do today. We are going to have a little chat about our endeavors. Okay, so as you may have gathered if you've gotten this far into the video, I am fairly bad at this, but I've been spending a lot of time on it. I have a problem with coming up with quick solutions. Well, not necessarily quick, but to some respect also creative. I have a problem where I have some initial idea and I struggle to jump in between different ideas when I'm problem solving. What makes me think I can get good at this? I feel like I've got the intuition to, I feel like I've got the ability to understand it. What I don't give myself enough of is practice and feedback. So one means of creating some sort of accountability within myself within myself is that if I spend more time on this platform explaining, putting in the time in, seeing my progress as I get along, surely I'll get better at it. It's not just about getting better, it's that feeling of struggle, that feeling of, okay, maybe I didn't know as much as I had thought. Maybe, I'm really weak at this thing. Maybe I should fix this. Maybe I should improve on this. Maybe I should read up on that. It's a constant reminder to bring yourself back down to earth, because nothing does it like a problem does. It's crazy, and I feel like that's important for me because, well, first of all, I enjoy this. It's fun. When I take the whole hustle idea out of it, I enjoy myself a lot. What I need to give myself enough time of is time to fail, but also time to improve. Because I haven't been giving myself enough time to improve, and it's a bit frustrating. And probably the most obvious thing I need to improve on is the use of my words, because I'm not as smooth-tongued as I would like to be, especially when I'm trying to convey my ideas. I just get twisted and I try to find the perfect thing to say, and I never really end up saying anything meaningful. And hopefully that will change as I spend time on this. And hopefully I can build a routine out of it. I can't hold myself to the stake and compare myself to BenQ all the time. Like look, I'm literally rated 997. I've come 12,000 in a Div 3, 8,000 in a Div 2, 6,000 in a Div 3, and 6,000 in another Div 3. Now, there's very bad trap that I can fall into. I could just be doing easy problems for a long time. Like I've done 135 problems with some little to no improvement. And that's because, well, the gap that I've been trying to jump wasn't too big for me. And in other words, the problem was just really easy. And I'm not learning as much as I could be. Like you saw now with this math problem. Like DP is fun. It's enjoyable. It's something that twists your brain, and it's something that I don't do enough of. There are a lot of hard problems that I could be doing, that I could be struggling with, and it's, in my opinion, more fun to be doing it on YouTube. And a part of me just wants to share, just to document, just to have something to look at in the future, because it'll be easy for me to do this for a week, and then I keep struggling for a week, and I'm like, oh, who's gonna want to watch me struggle for a week, struggling with a 1300 problem for over an hour, and then reading up the solution. Now maybe this is not for me. No, there's too many things that I feel like I've had that attitude with, and I haven't developed enough to really see where I could have gone with it. But this feels like something this feels like the first. This could be the first, is what I'm trying to say. We're gonna alternate these. It's not just going to be problems every day. Some days it's gonna be trying to learn some structure, maybe try to implement it, make some notes on Notion, maybe watch a YouTube video. I don't know. Watch some Enrico, watch some William, watch some second thread. I don't know. But we are here for it, and we don't have an agenda. We just have a routine. Yeah, that's what we're gonna call it. We're just gonna call it a routine. This is going to be our routine, and we're gonna stick to it as much as possible. Cool. No, I'm gonna sip on some. I don't have anything to sip on. Alright, I'll probably end this episode early. Hopefully I can stream it tomorrow. So I'm going to do one more problem. Maybe something, let's just do 1300 now. We can cap it at 1003 as well. Binary search, number of pairs. Sure, let's do it. Let's do this one today. Okay. You're given an array A of n integers. Find the number of pairs ij where the sum of ai plus aj is greater than or equal to L and less than or equal to R. Okay. For example, if n is equal to 3 and those are the values, and L is equal to 4 and R is equal to 7. Having to... Okay. Find the number of pairs. So we can sort the array. Okay, so we could probably break this problem down. That's my initial impression. So do they give us L and R? Wait, they give me T. The first line of each test case contains n, L, and R, and then the next n values are is the array. So let's do a test. So 5, 1, and 2. Just want to make sure this is still recording. Yeah, it is. It is included, so that's interesting.
You're invited to a new way of listening with Premium. Premium lets you connect to your speakers or TV and listen to your music ad-free. With super easy setup, you can connect to any compatible device and enjoy music without interruptions. Plus, listen on demand and play any song, anytime, even on mobile. Upgrade now to unlock Premium. Tap the banner to learn more.
This tends to happen sometimes. I kind of go numb. Like the box of nothing opens up and presents itself in front of you. And as I look at this problem now, I have too many ideas, but I'm not exploring them. Like I just stopped. Like I just got stopped. Stopped in my tracks, and that's the problem. That's what we need to work on. What do we know? We know that I has to be smaller than n, so we can't necessarily sort the array. I has to be smaller than j, I mean, not n. And then the rest of i's have to be in some range. What if we just don't sort it? So what if I keep it as it is? So say in the second example, 5, 1, 2, 4, 3, we hold the prefix sum, and then I can work on that, and then I can say I can pair 15 with two other numbers, so I can say plus 2. I can pair 12 with three numbers. I can pair 8. I can't pair 8 with anyone. I can only pair him with himself. Currently on 6. No, I can't pair it with himself anyway. Yeah, it can't be a single number. So that has to 12 can, yeah, 12 minus 8 doesn't work. 12 minus 6 works. Oh, you see, I made a mistake here. It's capped between 8 and 5. Can't even do 5, then it goes to 10. Can't even do 6 because it's then it's 9, because the range is 5 to 8. So then I can only pair it with 8. And the difference between them is 7. So then 15 can only get paired with one number. And then 12 gets paired with 6 and 5. And then 8 gets paired with no one. Oh my, it's the problem tags. I see problem tags, and then like in my mind I'm like, okay, where can I implement binary search? Where can I implement two-pointer? Where's the math? Oh, what's the data structure, man? I'm just not thinking. I'm not thinking now. I'm completely soft, but I'm gonna solve this at least. Number of pairs. This is probably div 3. Yeah, this is div 3. Oh gosh. It's fine. It's day 1. Today is warm-up day. Today is warm-up day. Considering that this is a prefix sum, then if the value itself is within the range, then I can add it. And then I get my desired 7. But that just feels a bit too slow. Then 2 pairs are suitable. So how can this be a 2-pointer? And how do we implement binary search without a sort? So we should be able to do some sort of sort. But how? How, gamers? How, Sway? Tell me, please. OBS is still good. Yeah. Still great. Still doing wonderful. Two-pointer please. I don't want to implement the slow solution. I don't want to make it slow. I don't want it to be slow. Because I must be smaller than J. Then it's kind of funky. You know what I mean? You know what I mean, boss? How can I do like a nice little sweep? Given that the values are always increasing, I can kind of do a binary search though. Given that I've made this a prefix sum, or rather I'm just adding the values on top of each other, then you have like some double for loop that will search for, not a double for loop, just a binary search value that's going to get us some boundary index, and then we just do a bit of subtraction, and then we get the number of pairs we can make with some value at the current index that we're at. I think that'll work. Ooh. Okay. What do you think? Maybe I should write it out in Studio first. Okay, so this, just for the sake of a legend, key tick. The blue ticks are like having looked at the solution, and the green ticks would be if I had got it myself. But this one is blue because I had to cheat. Ignore the rest. But okay, so this problem is called number of pair. Number of pair. This has an example now of 5, 1, 2, 4, 3. 5, 1, 2, 4, 3, and then let's get the text out. Let's write a bit of pseudo. So our IO routine is just going to build a prefix sum. Build a prefix sum into the array. And then for each value, wait, I just kind of want to make sure this works the other way around as well, just so that I can implement it a bit easier. Today is just one of those days. One of those dreadful days. What do I mean dreadful? I don't mean dreadful. I take that back. Don't say that again. Don't say dreadful again. It's not a good thing to say at all. But I just feel rather pop. Yeah, I said pop. Yeah, I said pop. But my head's not moving how it should. Maybe it's because the camera is on. Maybe it's because I'm a bit clapped. I don't know. But I just keep losing my train of thought. I literally just had a solution. Or at least I thought I did. It involved the prefix sum. And I was trying to figure out if I should do a binary search based on subtraction or addition, because I know that if there can be up to 10 to the power of 9 test cases, there's probably a really fast way to do this, and I'm not sure how. It's all set up to be 10 to the power of 4 number of test cases, 10 to the power of 9. There is a really stupid fast way to do this, and I feel like it's got well, clearly it has to do with 2 pointers, but I don't know how. Involves the sum of 2 numbers that are in some range. I'm just gonna see if I can look at it and see if I can derive something. Hopefully we can figure something out. So like in the first test case, I can pair 5 and 2. Then I can move the ticker from the index, the ith value, so the ith value of the 2 pointer to the second position, and then I can sum up 1 and 2, and then they don't. Well, not 1 and 2, 5 and 2, and then they do, and then I can add another one, and then I move over the ticker from 5 to 1. Then they don't, and then I terminate because I can't move any further. And the same would go for 5, 1, 2, 4, 3. That's why this problem is so well solved. I'll just read in the first 2 values, check their sum if it's within the range. 5 plus 1 is in the range, so I can add a 1. 5 plus 1, is it smaller than? Yes, it is smaller than. So then I can say 5 plus 2. Is 5 plus 2 in the range? Yes, I can add another 1. 5 plus 4 in the range? It's not. But 5 plus 3 could possibly be in the range. So what's the fast way of doing this? What's the crime in sorting it? I need a way to sort it. No. Because I has to be smaller than J. But it doesn't matter. Wait. It does matter. It doesn't. I'm gonna sort this again, right? Give me a second. Give me a second to breathe. I'm gonna sort it. And then, without muddling it up with a prefix, I can say, given that I'm at 1, I can pair it with 4 and 5. So I can pair it with 4 and 5, and 4 being the smallest true value, so then I can say 2 for the 1. For the 2 I can pair it with everything up from 3, so then I can add can add 3. And then the 4 I can't pair with 5, but I can't keep him alone either. Because in this case I get 6. That's the weird part. Oh no, for 3 I can pair to 4. So it has to be paired with the max. I have to find the max. And the min. Whoa, you have to find both, bro. Yeah, so then I can pair that guy with 1. And then 4 I can't pair with anyone, but then 5 I can pair alone. So then I get 7. So is that the binary search? Is that all they wanted? Okay, so that's one way to do it. Let's see another way. So if we sum this, a prefix sum involves more than one element. That's why it makes it a bit iffy. So yeah, that's what we're gonna do now. We're gonna sort the array, and then do a binary search for the largest for the max boundary, and then the min boundary, and then do a bit of subtraction to get the number of elements that we can do it with, and then we return the sum. Because I can't think of any other way right now. So yeah, we're probably gonna read the editorial and then we're gonna feel stupid, but that's the point. Let's try that way. So that, not a prefix sum, but how are we gonna? Wait, is it 2 seconds? Okay, it's 2 seconds at least. Okay, so we're gonna. But I don't see how we're gonna sort 10,000 arrays that possibly have a billion elements in it in less than 2 seconds. iRoutine read in and sort, and then for each run a binary search for the min value To be fair though, we can cut the search when the value at I is greater than our right boundary. So that can kind of help us, I think. Oh, well, I don't know how to run a complexity analysis, so I don't know if it's going to be fast enough. This isn't DP, but I'm just going to leave it in here. Okay, so number of pairs. I'm gonna try one more. I'm gonna try one more time. This is not gonna be fast enough. I do not trust it. I don't trust it. I don't trust it. Some iterative way. There is some way. It's a two-sum. This is, but it's that I smaller than J. That's just ticking me off. Wait, can I rearrange this? Wait, can I rearrange this and make this O of 1? Wait. If L smaller than or equal to AI plus AJ smaller than or equal to R, and L smaller than or equal to minus A1 smaller than or equal to R minus AJ. Wait, is this a thing? Is this a thing? Wait. wait. Please don't make this a thing. Okay, so some I where our left is 5. That's some I. So our value would be 5 minus 1, it would be 4. No, rather no, it's going to be 0 in that case. So 0 is smaller than or equal to, so we just need to binary search for that value. So what is that value in this case? So I'm starting over. If you are confused, I'm starting over from the most naive solution I can come up with, and it is here. It is right in front of my eyes. The most naive solution I can think of, but it will never be fast enough. But what we can do is try to make it faster. Baby steps this time, right? Just baby steps. Oh gosh, I'm gonna laugh at this one day, and that's why this will work. I'm gonna laugh at this one day. I think the lighting is still okay. I think the exposure is default, so it's fine. Is OBS still working? Still working good. How long has this been going on? 2 hours on the mark. We just hit the 2-hour mark, boys. Welcome to the 2-hour team, blood.
Upgrade to Premium and unlock access to ad-free music. That means any playlist or radio station you want without ad interruptions. With radio stations, create a collection of tracks based on the music you love. On any artist, album, song, or playlist, just click Go to Radio and listen to hours of similar music ad-free with Premium. Tap the banner to learn more.
Tired of having the same go-to meals? Get all kinds of yum you didn't know you needed. Go on, download the Mr. D Food app and discover over 8,000 restaurants and a world of delicious options.
Hmm. I don't know why it counted an 8-1. That's what I don't understand.
I don't do bank visits. Too busy streaming. I don't do forms or signing. I've got places to be. I do it on my phone. Quick and get back to doing me. I do it all for just $4.95 a month. I do banking with a MIMO account. Get yours online today. Let's push. Standard Bank. It can be. Standard Bank is an authorized FSP and registered
No
credit
idea if
provider.
this will
T's
pass.
and C's apply.
With speed. No idea at all. Wrong answer test 2, man. 9th number. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 3. I said 0 when it should have been 2. Cancel. What is my bag? What is my bag? What is my bag? Why didn't it work? I hate that about the command line. I can't go back. I can't go back to the line above. Once it's in, it's in. Why didn't I have to debug it? Okay, let's have a look. So it should pass. Zero, 1, 2, yes. Yeah, 0, 1, 2 should pass. So the mid answer is then. The mid answer perfect. Okay, then we make them unequal, then we go down, and then we say. Oh. But then it will never work. So then it returns 0. Okay. I think I see the issue. Because it has to start from min answer. And let's check. And we find our match. And we get out of there. Total is 1. Same story. Wait, what? Let's just look at the answer. No. Why do you keep doing that, kid? That's answer 1. Having sorted it. The 1 has to match to the 2. Not 12. Whew. Look at me getting all frustrated. Okay. Smaller than or equal to r, greater than or equal to l. Having added 1. So that doesn't work. Perfect. And then it has to take me down to 2, where my mid is 2. When my mid is 2, it works. And then skips that, and it adds 1. And my I is currently 1. And I say, what is the mid? So low is 2, high is 4, mid is 3. Doesn't work. Goes back up. But it pushed it. Shouldn't have pushed it. Oh snap. So it could have potentially been greater than R. Yeah, it was greater than R. And then it went up and it pushed low. It shouldn't do that. And I shouldn't do that either. F9 through till I end up at total. Okay, then I start again. Then it's going to push me. A minimum answer of 3. Minimum answer of 2. Doesn't work. That one works. Total is 2. I'm not liking the way this looks. I don't trust this one bit. I'm not gonna lie. Oh no. Test 1. Test 1, Kenneth. I'll tell you what, right? Today just doesn't seem to be it. Today is just not it. It's probably not beneficial for me to sit this one through. Yeah, I'm not even typing in things correctly. Okay, we are very humbly going to rage quit today. That's what we're going to do. Our brain just wasn't in it, and that was it. Maybe I'll try to solve them later when the camera's not on. But that's not the point. Anyway, yeah, I'm glad I did this. Pretty sure you're not going to watch until this point, but I'm glad you did this today. We've solved one. We've solved one. so yeah, I'll see y'all next time for another video.